Okay, so today we are going to talk about star formation, right? And as you can see, what I have written here is that this process is ought to be initiated by a fluid dynamical instability, and this is known as Jeans instability. Now let us try to understand what the Jeans instability is. So first let us consider a uniformly distributed gas. First part, okay. So this is suppose a very large block of uniformly distributed gas. This means the density over each part is constant. It is the same everywhere. Now suppose due to some disturbance somewhere from this side, there is a disturbance, maybe some particles or some photons or some asteroid, something comes and hits this gas cloud. So what will happen is that you can think of it, there will be a sort of compression. So it was the original position, this gas cloud. Now because of this compression, there will be the gas will be compressed somewhat. Now because of this, what will happen? Acoustic waves will start to move from this direction of disturbance towards everywhere, right? It will move everywhere, so on and so forth. So first we have a uniformly distributed gas, next disturbance approaches. After that there is compression in the gas, no problem. Next, because of that there is this disturbance, you see, this information will be travelled throughout the cloud, and this information of this disturbance being travelled will be carried on by the acoustic waves. Okay, no problem. Now let us consider a region of matter, a region of space in between the gas cloud. Now see what is happening over here. Previously the density was same, so all the particles were equidistant to each other, but because of this disturbance, you see, things have become compressed, right? Now it can happen that because of this compression, the gravitational force of this entire region takes over such that this region starts attracting particles from the nearby region. So we will say that this region starts collapsing. This is a possibility. But again, there is another possibility that the waves will not let this happen. The traveling acoustic waves will not let this happen. So there are two opposing forces. One is due to the disturbance, due to the traveling acoustic waves, and another is because of that there is compressed, density increases, and so gravitation may take over. Right? Now it has been observed that if this region is very small, now very small means very less mass, less overall mass. Now in gravitational force, F is equal to G m1 m2 by r square. So entire stuff depends on the mass, right? So if this entire region is very small, what will happen? The entire mass will be small and the overall gravitational force will not be that much. And in that case, the effect of the disturbance will take over. So no contraction. However, if this region is very large, then its overall mass will be large, and so gravitational force might be more, might be able to overcome the forces due to the acoustic waves disturbance, right? And at that time what will happen is that a fluid dynamical instability will start in and a gravitational collapse will start. So all of a sudden, even if this entire place has constant density, because of the effect of this disturbance, all of a sudden it keeps on attracting more and more matter, and this is known as Jeans instability. And in fact, all the stars, even galaxies and whatever other heavenly objects, right? Stars, galaxies, they are believed to be formed due to a small perturbation. Initially, even if everywhere there is constant density, because of a small perturbation, such a scenario can happen. And so, all this stuff are due to this fluid dynamical instability known as Jeans instability. This is very important. Now, when I discuss fluid dynamics, I will talk about the equations relating to those. Right now, let me talk about this approach of star formation. So, I am talking about star formation. Now, I am talking this has been initiated using Jeans instability, right? And I am talking in terms of the disturbance versus gravitation. Now, this concept of star formation, this can also be understood, but rather in a more simpler term, without the concept of introducing the disturbance. And you know what that concept is? The concept is, suppose we have a gas cloud, right? Now, this gas cloud has a mass, overall mass, and there are particles inside. Of course, this is not at absolute zero, right? It must be at finite temperature. So all particles have a kinetic energy and all that. And also, this gas cloud has its own internal energy. Right now, let us consider gravitational energy. So there are two opposing forces. One is gravitation, which starts to contract, and another is the kinetic energy, overall kinetic energy, which tries to push outward, right? Okay. So if we equate these two, the kinetic energy and the gravitational energy, and there, if we equate them, from there we can also get a condition of star formation, and from that condition, the mass that we will get, the minimum mass required for star formation, is known as Jeans mass. So this is what we will do next.